Video will talk about the operations on array. Although there are many operations can be performed on array, but basically the most important operations we are going to discuss, that is traversal of array, insertion in array, deletion of any data from the array, searching of any key if element exists or not in the array, sorting of array. We have already discussed searching and sorting techniques. Fine, you can check out in the playlist. In this video I am going to talk about how to traverse an array and how to insert a data in the array with their code, because insertion is also of three types. Maybe you can insert element at starting of the array, at the end position of the array, or at any position, at any specific position in the array. Fine, so I am going to talk about these operations, traversal and insertion, with their code. Fine, see, besides these operations, many operations can be there, like find minimum and maximum element from the array, find duplicate elements from the array, reverse of an array, find second largest element from the array. So now first of all we will discuss traversing of array, or you can say traversal of array. Now what does this traversal means? Traversal means visiting every element of the array exactly once. Fine. Suppose you can take one example, you have 5 apples and you are going to point your finger at first apple first of all, then second, then third, then fourth, and then fifth, something like this. You are traversing all the apples. So in this case we are going to traverse all the elements of the array, and output should be what? You should print the elements of the array. Whatever the elements in the array, we are going to print those elements. So I am going to see this with the help of a code. See, let us take, we have this array, array name is A, the size of array is 5, index would be from 0 to 4, and these are the elements in the array. How the data is to be stored, because each integer is going to take 4 bytes in typical compilers. So address, suppose base address memory manager has allocated to the array base address, that is 100. So for the next integer, for the next element of the array, the address would be what? 100 plus 4, because this one integer will take 4 bytes. So that is 104, 108, something like this. I have already discussed in the previous video this concept in detail. Fine. So see now how we are going to traverse the array. We are going to take one variable I started from 0. Now we will see what is there at this place. 6, we are going to print this 6. Now this I would be incremented, I is here now. Now here what is the value? 2, then 2 would be printed, then I would be incremented, then here, then here. Now and like this the values would be printed, and I would go from 0 to 4, that is from 0 to size minus 1. Size of array is 5, so size minus 1. This is how we are going to traverse the array, and you are going to write down the code for this. Now how we are going to write down the code? First of all, see, I am also going to discuss how to initialize the array, how we are going to take these elements, and initialization would be of two types, at compile time, at runtime. So in this video, at runtime I am going to ask from the user what elements the user wants in the array, how to populate the array at runtime. Now see, let us check. So initially we don't have anything in this array. So first of all what you will do, you will just write header files and all. I think you can write that thing. Now let us take, I am going to declare an array of size 50. See, actually when you are using the array, when you are storing the integer, then you can store only 10 integers. It's up to you, less than 50, but you cannot store more than 60. Why we are taking this 50? Because see, it is fixed size. Once you declare the size of array at compile time, you cannot change it at runtime. Fine, that is drawback of the array. But one another drawback is that array is not having any bound checking property at runtime. So it is the job of the programmer only to check, to write down the code for checking the boundary of the arrays in program only. Fine. Now what is that bound checking? I will discuss later. So see, I have declared array of size 50. Now how many bytes would be allocated by the memory manager? 50 into 4, that is 200 bytes. So something like this. If this is our memory, so now see, in the memory how many bytes would be allocated? And that is 50 into 4, because one integer will take 4 bytes, that is 200 bytes. So suppose the base address is 100, so 100 to 299, these bytes would be allocated to this array, this space. But here we don't have any data now. We are going to take the input from the user. Now next thing is you can ask from the user that how many data the user want to insert in this array. What is the actual size of the array? This is the maximum size. Fine. This is the maximum limit. So see, you can ask from the user printf enter size of array. Printf is a function, standard function that is used to print something on output screen, and scanf is used to take input from the user. Now user will enter what, suppose size is 5. I want to insert 5 elements only. So here you will write %d, because for integer the format specifier is %d, for float it is %f. So here you will write address of. Now if user will give something, some input, that is some integer value, then obviously that value should be stored in memory. And how value is to be stored in memory? Using variable. So you have to declare one another variable. Fine. So let us suppose we have declared array, and I am going to declare here only the one variable name, that is size. Fine. And I am going to write here address of size. So now the compiler will see this line, then what compiler will do? Compiler will allocate for this variable, it will allocate 4 bytes somewhere in the memory, from 304 to 307 for the variable name size. Fine. Now this is what address of operator. Address of operator means when user wants to insert, when user will insert the data, then compiler should know at which address you are going to store the value. So this address means this would return at 304 you are going to store the value. So suppose user entered the size 5. So here you will write here what is to be inserted. 5 would be converted into binary form and 5 would be inserted. So here you will insert 5 in these 4 bytes. Fine. Now we want to populate the data in this array. Now the size is 5, so I want to insert 5 values. Fine. Now how the value is to be inserted? I would be started from 0 till 4, till size -1. You have to take one for loop. I have already discussed there. So what you will write? You will write what? Printf enter elements of array, and you will write one for loop, and this loop would be started, I value would be started from 0, I would be less than size, less than 5, that is 4, 0 to 4, index would be 0 to 4, and that is I plus plus. And in for loop you will write, because to take input from the user we use scanf function. Here you will write same %d format specifier, and address or where you are going to store the values. First value would be stored at 0th location, means at this location, in these 4 bytes, 1, 2, 3, 4, these 4 bytes. Next would be stored in these 4 bytes. So now here you will write a of I. Fine. Address of array name is a, and at which index you are going to store. Index would be started from 0 to 1, 2, 3, 4. This is how I am going to represent it. 0, 1, 2, 3, 4. Each block is having these 4 bytes. Fine. So this address is to be allocated. Now when I value is 0, then value would be stored at address of a of 0. Address means at value 100, a of 0 means at this index. Fine. So now user will insert the values. Suppose user has inserted the values 6, 2, 0, 4 and 5, because loop would be started from 0 to size is 5, 0 to 4. So that is why 0 to 4 the array would be populated. Now how this array is to be traversed. Now we are going to again start a loop from here. We are going to check, we are going to access this element, and we are going to print. Output should be, you are going to print the array. What are the elements in there? You are going to print that. Fine. So for printing you will write what? One for loop. Again for loop would be there. I would be from 0 to 4. Fine. So you can write here printf elements in array are. After printf you will write one for loop. I would be started from 0, I would be less than size, or you can say less than equal to size minus 1, I plus plus, and here within this for loop you will write what? Now we are going to print the array. So you will not write scanf, scanf is for taking input, you will write here printf. Percentage d is for integer because data type is integer, and here simply you will write array of I, because in the previous video I have told you for accessing the element of the array you simply write array name and in brackets you will write index. So I would be 0, then a of 0 would be printed, this 6, then I plus plus, I is 1, then a of 1 would be printed, that is 2, like this from 0 to 4 values would be printed. So this is now the traversing of the array. See, here we are using one more variable, that is I, so you have to declare this variable here before, that is I. Fine. So I guess you can write the header files and you can execute this program. So next we will discuss now how data is to be inserted in the array at specific position, because if you get how data can be inserted at specific position, then you can easily modify the code for inserting the data at beginning and at the end of the array. Fine. So now we will see how to insert an element at a specific position in array. See, I am going to take the same example. Array size is 50. Now first of all you have to take care of this thing. If array is full, then that is overflow condition, you cannot insert. So in the program you have to write that condition also. From 0 to 49 we have index, this address would be 296. So if you have inserted all the 50 values, and then you cannot insert any other value. If array is not full, then you can insert. Fine. In this case we have inserted only 5 elements because size we have taken only 5, but we have space for storing 50 elements. So still you can store how many elements? 45 elements. See, another thing you have to take care, I have told you there is no upper bound checking concept of arrays in C. Like this, if you take here int a is equal to 50, fine. Now memory manager has allocated to you how many bytes? 200 bytes for storing 50 elements, and if you write down here enter size of array, and if you enter the size 51 or you can say 60, then user can insert 60 values also, but that is not actually correct, because initially how many bytes has been allocated? The space for only storing 50 elements. How you can store 60 elements? So that is not a concept of bound checking in the array. The programmer has to take care of this thing. The programmer has to write down a code in the program only to check the upper bound limit of the array. Fine. So here only after inserting the size you will write a line that if size is greater than this upper bound limit, this 50, then you will print what? Overflow condition. Else you will write down that enter the elements of the array, and other code you will write down in the else block. Fine. Now see, I am going to take the same example. We are having only 5 elements. Fine. Now how to insert? First of all we will discuss with the help of one example, this example, then we will write down the code. Fine. Now suppose at position here, at position 3, see, I am going to take index and position different thing. Somewhere you find out that index is same as position, somewhere it is written that at position 2 you are going to insert, so index is also 2, but here I am going to see, here I am going to consider position is 3rd but index is 2, because as you can see position is 1, 2 and 3, fine, but index is 2. So I am going to insert here. So here I am considering this is the position, position is equal to 3, here I am going to store the value, here I want to store the value. So now what you can do, can you directly store a value? Suppose I want to store a number 10. So if I store directly here 10, then what will happen? Then you will lose 0, and that should not be a case. Fine. We want all the previous element as well as we want some extra element that you want to insert. So you cannot do directly this. So another approach is what? You can shift these elements to the right side. Fine, because still we have space left in the array. So you can shift this 5 here, then this 4 here, then this 0 here. So here what you can write, this 5 after shifting. Now this 4 would be shifted here, so in the place of this 5 you will write 4, Now 0 would be shifted in the place of 4 because 4 would be lost and 0 is there. Now here also we have 0. Till this position where you want to insert, till that position you are going to shift to the right, and from where you are going to start the loop, we are going to start the loop from here, from the last element of the array, or you can say from size minus 1. See, size is what? 5, but index is 4. So you are going to start the loop from 4. I would be started from 4 and I would be decremented. Now I is equal to 3, now I is equal to 2, and if I is equal to 2, then you are going to stop. Means we have found the position. We have 0, 4, 5 here. Now 0 is duplicated, so we can insert 10 here. We can insert 10 here. We can overwrite this 0 now. So that is how we can inserted this number 10 at position 3. Position 3, index is 2. Fine. So how we are going to write down this loop? See. So here we are also taking more inputs from the user, that is number you want to insert and at which position you want to insert the data. So for storing these two values, you have to declare two variables, that is num and pose, right? So now same, enter the size of the array, size you have to enter, then you are going to enter the elements of the array, and if the size this size of the array should be less than or equal to this 50. If size is greater than 50, then you cannot insert anything extra element in the array. Fine. So now after the scanf, you will write if this size is greater than 50, this size, then you will write what? Print overflow condition. You cannot insert. Fine. And after that in else block you will write from here printf, and after that you will write in else block. This is how we are going to check the boundaries, upper bound of the array. Because I have told you there is no concept of bound checking of arrays in C. So programmer has to write down the code itself for the checking of the boundaries. So these two more inputs you will take from the user. Enter data you want to insert, that is scanf %d address of num. Fine. For the num also 4 bytes is to be allocated in the memory, and enter the position at which you want to insert, and for position also 4 bytes is to be allocated in the memory. Now what you will do, you have number also, you have position also. Suppose number is 10 and position is 3. Now the swapping would be done. Fine. From where you will start the swapping? From the last element only. Why so? Because see, at this position, at third position you want to insert, and if you say I will swap from this position only, first of all I will swap this element here. So if you swap 0 here, then this 4 would be overwritten, you will lose this value 4, and here you will insert this 0. Now from where you can recover this 4? We cannot recover this 4. So you cannot start the swapping from here, you have to swap from this position only. Fine. So now you will write down a for loop for swapping, and we will start this for loop from where? We have started from here. Initially we are having only 5 elements from 0 to 4. So we have started our loop from here and we have shifted this to this. Fine. Two ways are there. You can also start our for loop here from size. See, size is 5, so you can start from the for loop here, I is equal to size, that is also fine. And you can also start from here, that is size minus 1. So here I am starting from size minus 1, and from where I should be greater than equal to position minus 1. See, I will go till the value 2 and position value is 3. So 3 minus 1, that is till 2. So I should be greater than equal to 2. From here to here you are going to swap, and here you will write I minus minus. Now what we are doing, we are inserting this value, previous value, to I plus 1, right? So how you will write here? A of So here you will write A of I plus 1 is equal to, see, A of I would be shifted to A of I plus 1, that is at starting I is equal to size minus 1. So I is equal to size is 5, so I is equal to 4. 4 is greater than equal to position minus 1, 4 is greater than equal to 2, fine. So control will go here. So a of I plus 1, that is a of 4 plus 1, 5 is equal to a of 4, and it means this a of 4, this value would be transferred to a of 5. That's what we have done exactly, fine. Now again I minus minus, that is I would be 3. Now a of 3 plus 1, that is 4, is equal to a of 3. Now a of 3 value would be transferred to here. Now again a of 2 value would be transferred to here, fine. And when I becomes 2, then also fine. When I becomes 1, then 1 is not greater than equal to 2. That is why we are going to stop, we are not going to swap this value, fine. So now after this for loop, what you will do, you are going to insert now the data, where you are going to insert a of position minus 1. See, position is 3, but we are dealing with index, na? So a of 3 minus 1, that is a of 2. A of 2, here you are going to insert 10, but position is still 3, 1, 2 and 3, but index is position minus 1. So here you are going to insert number, and after inserting this number, now array size becomes what? 6. So now size becomes size plus plus, right? Now finally you will print this array. How you can print this array we have discussed when we were traversing the array. You just write down a for loop. In for loop you will start from 0 to the size, fine, and you simply write printf %d and a of I, and these all values would be printed. This is how we are going to insert the data at specific position, fine. And in this case you can also write down one more condition, that is you can also write down a bound on position. If position is less than 0, that is in minus 1 or minus 2, then you cannot insert, that is invalid position. And if position is greater than the size is 5, so we have from 0 to 4 here. So within this range you can insert. Position can be 1, 2, 3, 4 and 5. Although position can be 6, here also you can insert, but position can be like 10. Here you cannot insert. Why so? Because in arrays you are going to store the data in consecutive location, or you can say continuous locations. So it's not like you have data from 0 to 4 and you skip these positions and now you are going to insert here. That is not possible in array. So here you can also write down one if condition on position. After this position here, so here you can write if position is less than equal to 0, because if we take position is equal to 0, then here 0 minus 1, that is minus 1, that is invalid. So position is less than equal to 0, or position is greater than size or size plus 1 you can say, fine, because size is 5, so here also you can insert at 6th position, that is also fine, but after size plus 1 you cannot insert. Then you will write what? Printf invalid position. And after this, if in else block you will write this for loop, and you will also going to print the array in this else also. After that you are going to close this else, fine. So this is how you can insert a data at any specific position. You can insert at this also, you can insert at the end also, fine, using this method. But suppose you don't want to ask from the user about the position, you know that you want to insert at the beginning only, at the 0th location or at the first position. You don't want to ask this enter position and scanf like this. And second case is you want to insert after all the data at the end of the array. You don't want to ask from the user the position. Then how you will do? You are not supposed to write in that case these lines, printf enter position and this, and you have to modify this for loop a little bit, fine. So this would be as it is, fine, this would be as it is. You are going to write this thing, I am going to rub this thing, and I am just going to write down this for loop, this updated for loop at the beginning. How you will insert at the beginning of the array. For inserting at the beginning, you will have to shift all these data. Same, you are going to start loop from here, size minus 1, and loop will go till 0. Because obviously you are going to insert here, so you are going to swap all this data to the right side. So simply you will update this for loop like this. I is equal to size minus 1, same, and I should be greater than equal to 0 now. You know the position, so no need to do position minus 1. And I minus minus. Same you will write a of I plus 1 is equal to a of I. Fine. And here you will write what? At a of 0 you want to insert number. And simply size plus plus. No need to write position minus 1 because you know the where you want to insert at a of 0th location. Fine. And if you want to insert after all the elements at the end of the array, then what you will do? Then that is very simple. No swapping would be done. Fine. So now how you will insert? Simply you just enter the data you want to insert. No need to ask the position. No need to do this swapping and all. Fine. Simply you will write a of here. Here means you can say that size, a of size. Size is 5. So at index 5. At here at index 5, because if size is 5 then data would be from 0 to 4. So at a of size you can insert the number, and size plus plus you can do. So now if we discuss the time complexity, then see, if you are given some position, suppose position is given this one, you are going to insert data here. So you are going to shift all the elements to the right side. So time complexity would be theta n. So in best case it is 1 and in worst case it is theta n. And basically time complexity, the time taken depends on the position given. Fine. If position is this one 1, then you have to shift all the elements. Fine. That is n shift would be there. If position is this one, then n minus 1 shift. Then position is this one, then n minus 2 shift, like this. If position is this one, then no shift operations. So rather than writing this, you can also write theta n minus p, where p is what? Position. It depends on the position given. Fine. Now see, this is now unsorted array. So now the best algo to insert a data in unsorted array, because you are not concerned with the ordering of the array, then the best algo is what you can do. See you want to insert 10 here at position 3. Initially the array is this one. Rather than shifting like this, what you can do, because array is unsorted, so you can simply take this value, insert at the end of the array, and here you can insert directly this 10. So you can simply write these two lines at a of size. Size means size is equal to 5. So a of 5 you can simply store this 0. 0 means from a of position minus 1. Position is 3. 3 minus 1, that is 2. And at 2, at position minus 1, you can insert number. And this will take how much time? Constant time, that is 1. So in exam, if question is asked, then what you will write? You will not write that in best case this one, worst case this one, or this one. No. Maybe options would be given, but in exam you are going to write down the best algorithm time complexity. So the best time complexity is theta n in unsorted array. Fine. In sorted array, what you have to do, in that case you cannot do this thing. You cannot simply take this value, insert at the end and do this thing. No, you have to take care of the relative ordering of the elements in sorted array. In that case you are going to do this shift operations. So you can apply this shifting method in this unsorted array also, but the best method is what you simply do this thing. So in next video we will discuss how to delete data from the array. So I will see you in the next video. Till then, bye bye, take care.